Hello, students. Welcome to class today. I'm going to be dealing with partial fraction. So, the instruction is for us to resolve the expression into partial fraction. Now, let me let you know some things about partial fraction. You see, partial fraction is a way of breaking down a single uh, fraction, okay, a single algebraic fraction into components, into simpler components of fractions. And that is exactly what I'm going to do today. Now, the question we have on the screen is a question where the denominator has factors that are linear and non-repeated. Look at it. Look at the factors. The one I underlined with red. Okay, they are all factors, they are non-repeated, and they are all linear because the power of x is 1 in each of them, and they are not the same, so non-repeated. Now I want to show you how we actually will deal with this. Since we said that is a way of breaking down a single fraction into smaller components, let's see this. Now look at the first one. If you check, the factor is x plus 4, so let's have it this way. Then plus the second one, look at it, is x minus 7. Then plus the third one, the denominator is x plus 1. Why I decided to go through this way is to show you this. Now you see, the rule in short is that once the denominator is linear, okay, then the numerator is going to be a constant. That is to say, if the power of x, generally now, if the power of x at the denominator is x raised to power n, then at the numerator, the power of x is going to be n raised to power n minus 1. Now, in this case, since it is x raised to power 1, then at the numerator is going to be x raised to power 0, which is actually a constant. So I will now have this as just an unknown, which is a. Now, the same thing here, but this is going to be to differentiate, and this is going to be c. So this is how we resolve this into partial fraction. This is the very first step we need to take. All right. Then we move to this. Now, check out what I'm going to do. Now, if I decide to get the LCM, of course, the LCM is the same as this. All right. X minus 7, then x plus 1. You agree with me that for the first, a will be into x minus 7 into x plus 1. Then plus we have b will be now into x plus 4 and x plus 1. Then the last, which is c, will be into x plus 4 and x minus 7. So this is what I have. Now putting it side by side, like on the screen, you agree with me that the denominators are the same. So of course the numerators are going to be the same. So I make this conclusion now that a into x minus 7 into x plus 1, then plus b into x plus 4 into x plus 1, then plus c into x plus 4 x minus 7 will be equal to the numerator there, which is x squared plus 2x minus 3. Now, when you come to this, you've gone a bit far into the work. Now, what you need to do is to find your coefficients a, b, and c. Now, listen, there are two basic methods. One, we have the cover-up method, and we have the comparing coefficients. So it depends on the question, but for this particular question, I'm going to be using cover-up method. All right, but subsequent videos, I'm going to show you how to use the comparing coefficient method, okay, because each question is unique. Now, in the cover-up method, what we do is we assume or we eliminate the coefficients. You see, if I want to get just a, that is, I want to eliminate b and c, I will say let my x be equals to minus 4. Just by this, I'm going to eliminate this. I'll eliminate this. So that is the idea. That is the cover-up method. So what I'm going to have now will be a into minus 4 minus 7. Then I have, instead of x, I'm going to have minus 4 plus 1. Then plus b into, I have minus 4 plus 4. then I have minus 4 plus 1, then plus c into minus 4 plus 4, then I have minus 4 minus 7, then is equals to minus 4 all squared, then plus 2 into minus 4, then minus 3. Now having this is what is going to happen. You see, this is 0, so it cancels out everything, and this is 0, it cancels out everything. So I'm going to have a down into minus 11, then I have minus 3, then is equals to what I'm going to have here. Check it out here now. This is going to be 16, then minus 8, then minus 3. So I'm going to have 16, then minus 8, of course, then I have minus 3. All right. So I'm going to have minus, or not minus now. I'm going to have 33a is equals to 5. So a is equals to 5 all over 33. So I've gotten the first, which is a equals to 5 over 33. Then I will now move to eliminate so that I can get b. Now in getting b, the simple thing I would do, just like the previous, is to say let x be equals to 7. Now if x is equals to 7, I'm going to have, now once I have this, just like I did in the first case, now you agree with me that 7 minus 7 is 0, so everything there cancels out. Then 7 minus 7 in this case is 0, so everything there cancels out. So I'm going to have b, then I have into 11, then into 8. All right, then it's equals to 49 plus 14 minus 3. So this is going to be 88b will be equals to 60. So b is equals to 60 all over 88. Taking it to the lowest term, I think 4 can go into it. So that I'm going to have 15 over 22. So I'm good with b. Now we'll go straight to get my c. Now you agree with me from what I did in to get a and b, you can actually get c by saying let x be equals to minus 1. Okay, the same process. So let x be equals to minus 1 to get c. Now let me show you what it will be. Now look at it on the screen. So just like we did, if you check, minus 1 plus 1 is 0. So everything here goes out to be 0, and everything here goes out to be 0. So what I'm going to be left with will be c down into 3, not 4 again, because minus 1 plus 4 is 3. Then I have minus 8. Then is equals to, here I have 1, then minus 2, then minus 3. So I'm going to have minus 24 c is equals to minus 4. So c is going to be minus 4 over minus 24. So that minus goes with minus, the answer is 1 over 6. So I have my c. Now, in summary, I have my a, I have my b, then c. Of course, a, we said a is 5 over 33. So I have 5 over 33 in this case. And the second, I have 15 over 22. So I have 15 over 22. Then the third is 1 over 6. Now this is what I have. But recall, we established this from the beginning. Now since we established it from the beginning, we are going to substitute the values of our a, b, and c to get our solution. So in this case, a is 5 over 33. So I'm going to have 5 over 33. Okay. Let me write it like this. I'm going to simplify it. You see it now. Then I have 15 all over 22. Then I have over x minus 7. Then plus c, which is 1 over 6. Then all over x plus 1. But you see, you can rewrite this and simplify it completely as 5 all over 33 into x plus 4. then plus 15 all over 22 into x minus 7, then plus 1 over 6, okay, into x plus 1. So I've succeeded in actually writing this or resolving it into partial fraction. So this is my final answer. I have resolved into partial fraction. Now I'm going to other videos on other types of partial fraction to resolve them. I need you to stick to these videos, watch them. I want to believe you understand this topic very well, okay? And don't forget to subscribe. So thank you so much for watching.